new recording. Okay, number 20. Still, but this term you pretty sure you have to use the rule because there's no alternate way for you to do this problem. Okay, so they say they want to take the limit of cosine x over 1 minus sine x for x equal to pi over 2. What if you plug in or direct substitute pi over 2 into it? You have cosine of pi over 2 going to be 0 and 1 minus sine pi over 2 going to be 1 minus 1, which is also 0. So lost the rule again, right? Lost the rule for this one because in the form. And now you have limits of cosine x, taking the derivative of that, divided by 1 minus sine of x. You also taking the derivative of that. So x equal to pi over 2. Doesn't matter for the positive here or negative here, because you can take that's the rule and then plug in. Okay, so now taking the derivative of that, you have negative of sine x, right? Top one will be negative sine x. What about the bottom? Negative of cosine x. Okay. Okay, so negative over negative going to be positive, right? So you're going to have just limit of sine, now you can actually plug in. You don't have to take limit again, to write limit again, but yeah, you can just direct substitute. You have sine of pi over 2 divided by cosine of pi over 2. What is sine pi over 2? Oh, actually, you know what? Cosine of pi over 2 going to be 0. Right? But sine pi over 2 equals 1. Well, for this case, it's going to be a infinity, but I don't know if it is a negative or positive infinity. So I had to come back with the pi over 2 here, which is in the right hand side pi over 2. So in the right hand side pi over 2, okay, so for that case, actually, let me draw the sine. Let me draw the sine function. Right. Here is 0. And here is here's pi over 2. So after pi over 2, what happened? There's from the right to pi over 2. You have as a Let me see. Maybe.
Don't we actually look at the tangent graph because it becomes tangent sine over cosine?
Oh, right. So I can change it to become tangent of pi over 2. That's better. That's good. That's good. Yes. Uh, if you, oh, I mean, you can just take it become tangent of x and limit for x go to pi over 2 on the right hand side. Oh, okay. So if you, so for this way, maybe it's make you more complicated. Should make it become tangent better. Okay, that's good. So if you have limit of tangent of x, uh, for x go to the pi over 2 from the right hand side, and you can know that that's going to become a negative infinity if you take a look at the deadmost. Let me show you. Oh, wait a second. So tangent x, right? This graph of tangent x. So you can see that for pi over 2, which is around here, right? Then the graph just going downward to pi over 2 and become negative infinity here. Okay, so easily you can see that that's become a negative infinity. Okay, so okay, let's look at the solution. Oh yeah, so they go by the tangent of x, and they finally just say it's going to be equal to negative infinity. Okay, good. It is a good part. Any question for this? Okay, so let's move to question number 21. Find find two positive number, right? Say, since we are looking for two positive number, so we're gonna say x and y, right? The product of them is 25. So I know that x times 5, so x times y is equal to 25, right? And sum is minimum. So we want sum, so x plus y, say p equals to x plus y, and we want p is minimum. Okay, so we did have a function of, sorry, an equation of x and y. So we need a relationship between x and y. So then later on, I can just plug in this function, so I can find the derivative of it to find the minimum of p, right? So I'm gonna say I want to eliminate y, so I just isolate y alone. I have y equal to 25 divided by x. Okay. So now I can just, substitute in here in the p. I have x plus 25 over x, right? So for this one, you can have you know, maybe you can write it as like x plus 25 times with x to power -1. Okay. Remember that we have x and y are positive number, right? So x and y it's just always greater than 0. So that is domain of x and y. Okay. Because we try to find the minimum of p, so we need to take the value of p, right? We need to find the critical numbers and then try to find the mean. Okay, so p derivative equal to what? 1 plus 25 times -1 times x to power -2. Can everyone follow me?
Yeah.
Yeah, I follow you.
Good. All right, so now stop me if you cannot. Okay, so now I have p derivative equal to 1 minus 25 times x to the power 2. Okay, so I actually now can convert it, you know, make it become 1 minus 25 over x squared like this, right? See that? So, okay. So we have x squared minus 25 over x squared. Right? It is p derivative. Right. Okay. So what I should do now? What's the next step should I do? What are we doing? Why we have to do this step?
Get the critical numbers.
Critical number. Good. Critical number. So we have to set p derivative equal to 0, right? So I have x squared minus 25 over x squared equal to 0. Now, what I should do? You guys still remember? How can you solve this one? Forgot already? So let the top equal to 0. X squared minus 25 equal to 0. It's good? So you have x squared will be equal to 25. Okay. And someone say x equal to -5 and 5. But remember that the domain is x and y greater than 0. So we don't even need to care about the negative number. So only x equal to 5 gonna be the one that we care. Okay? We carry only x equals 5 is a critical number. So now what? we need to take the second derivative, right? To find if x to find its minimum. Second derivative. What is second derivative going to be? 2x, right? 2x. And if I plug in x to 5 and see what happened with the second derivative, right? I have 10, which is greater than 0, positive number. So that's give me a happy face. Happy face give me a minimum because the mouth right here, the mouth right here, right? Minimum. So then at x equal to 5, we're gonna have a minimum sum of x and y. Okay, so we need to find y on it. So I have x equal to 5. So then y equal to, we have to come back with there's a relationship here. 25 over 5, which is also equal to 5. Okay. Any question? So 5 gonna be the answer here, right? Yeah, smaller and larger number just equal each other. So 5. Okay, so let's check the solution and see if I am doing correct or not. Maybe wrong. Let's see. Leave. Okay, so they are having 5 and 5. Good. So we are doing correct. Okay, so we finished 21, 22. Sorry, 21 only. Okay, so let's see. Is there any question right now?